Let's keep going with this idea to calculate the limit of a difference quotient. Again, this is a preview of things we'll be doing in the future, but for right now, it's just a special kind of function. So I want to calculate the limit as my variable h goes to 0. And I'm going to have a fraction, or a quotient. And let's take the square root of 4 plus h, and I'm going to subtract off the square root of 4, and this will all be divided by h. Now, h equals 0 is not in the domain of my function. So in order to solve this problem, using my removable hole, my removable discontinuity idea, I want to find a different way to write this function so the formula is valid for h equals 0. What I'm going to do is I'm going to rationalize, right? I've got some square roots in here. So I'm going to multiply on the numerator and the denominator. And what am I multiplying by? I will multiply by 4 plus h plus the square root of 4. And yes, I know the square root of 4 is 2. I'm just keeping it there to match the formula I was given. Now when I multiply this all out, I'm still operating inside of this limit. But let's see what I get. On my denominator, I have a pretty easy time. I have h times the square root plus 2h. On the numerator, I've got to FOIL everything out. So square root of 4 plus h, square root of 4 plus h is just going to be 4 plus h. I've got plus 2 times the square root. I've got minus 2 times the square root, and those will cancel. And then I have to subtract off 4, right? Square root of 4 times square root of 4. Now you see why I kept the square root there. Just makes things a little bit easier. Let me cancel the positive 4 and the negative 4. So I have 4 plus h minus 4. That's just an h. This is all divided by h times square root of 4 plus h plus 2h. And now, oh, I have preemptively distributed here. Maybe I should not have distributed that. If I'm going to cancel this, I need to take an h off of every term in the denominator. So I can say, let's get rid of the h on the top. Let's get rid of the h from every term on the denominator. And see what I get. So this is the limit as h approaches 0. The numerator is going to be 1. The denominator is going to be the square root of 4 plus h plus a 2. So, all the steps that I've been doing here, I multiplied by the same thing on the numerator and the denominator. That doesn't change the value of the function. I simplified, and I canceled, and I'm left with something different. These two formulas will give me the same value for any h besides 0. I'm not allowed to put 0 into this formula because of the denominator, but this formula will take a 0 just fine. So I can go ahead and say that this is going to be whatever I get when I evaluate for h equals 0, 1 divided by the square root of 4 plus 0 plus 2. That's going to be 1 divided by 2 plus 2, or a quarter. So, what did I learn? If I have a formula which does not accept the limiting coordinate here, h is trying to be the coordinate 0, I'm not allowed to put a 0 in this formula, I can rewrite and I can simplify to get a formula which will work. And all I'm doing here, if I had a graph of this function, is I'm paving over a hole in the graph.